All right. These are notes from chapter 5.5. This is exponential rule for base A. So basically, a base that is other than E. We have to follow this rule. So if we recall, the derivative, we know that derivative of e to the u is simply e to the u times u prime. But the derivative for a to the u, and a represents a value other than e, like 2 to the x or 3 to the x or any value raised to the x, we have to adjust for the fact that it is not base e by saying natural log of a times a to the u times u prime. So if you notice, this does resemble a lot like the rule for e to the u. We still have the original function intact times u prime, but then this natural log of a just allows the problem, the rule to be adjusted for the fact that this is not base e. Okay. So if we know the derivative rule for a to the u is natural log of a times a to the u, then the integral of a to the u, okay, must be basically the same form as a to the u. We just have to bring this natural log of a over, right? So if you think about the process going backwards, the integral of a to the u will simply be a to the u divided by natural log of a. So that's exactly what's happening here. The integral of a to the u du is equal to 1 over natural log of a times a to the u plus c. Okay? Or you can think of it as a to the u over ln of a plus c. Okay, either form is fine. One thing to keep in mind is that natural log of a is a constant. So we're going to treat this like a constant. If you see a natural log of a, you can always, it'll have the same properties as other constants or as other coefficients in the problem. All right, let's look at example 1. Integral of 2 to the x. So we have to use the rule a to the u because this is not base e. So the rule is integral of a to the u is equal to 1 over natural log of a times a to the u plus c. No need to go through U-substitution because this is simply an x, so we just follow the rule. 1 over natural log of a, in this case is 2, times the original function, unchanged, plus c. And we can also write it as 2 to the x divided by natural log of 2 plus c. Okay, our a value here is this base, the 2. All right, number 2, we have something more than just an x as an exponent. So we may have to go through U-substitution here. This is in the form of a to the u. So we have our u value being 3x. Our derivative is simply going to be 3. We solve for dx. dx equals du over 3. We make our substitutions. Integral of 2 to the u times du over 3. So we replace the 3x with u, replace the dx with du over 3. Now the 3 is a coefficient, so we pull that in front. And now we just follow the rule. The integral of 2 to the u is simply 1 over ln of 2 times 2 to the u plus c. Or you can combine all this to be one fraction as 2 to the 3x all over 3 natural log of 2 plus c. Right? And we are replacing the u value back in terms of x, so 3x. All right, number 3, integral of 3 minus x times 7 to the 3 minus x quantity squared. So if you look at this, hopefully you can see that this is in the form of base a raised to the u. So if we let this exponent be the u value, then hopefully we can cancel out with this remaining 3 minus x. So our u value is 3 minus x quantity squared. So if we want to find the derivative in this form, we have to go through chain rule. So chain rule, take care of the outer function's derivative first, bring the 2 down in front, 2 parentheses 3 minus x, subtract 1 from the exponent, 2 minus 1 is 1, multiplied by the inner function's derivative. So 3 goes to 0, but negative x turns to the negative 1. Okay. So once we're in this form, we can solve for dx. dx is simply equal to du over negative 2 times 3 minus x. We make our substitutions. We have a substitution in for 3 minus x quantity squared, which is u. We have a substitution for dx, which is du over negative 2 parentheses 3 minus x. So here we see the 3 minus x will cancel out nicely, leaving us with negative 1/2 in front, integral of 7 to the u du. So we can apply the rule for integral of a to the u. Okay, so negative 1/2 stays. The rule is 1 over natural log of a, so in this case 1 over natural log of 7, times the original function, 7 to the u plus c. And then we combine this all as one fraction. The u value gets replaced in terms of x, so 3 minus x quantity squared. Hold on to the negative, and the denominator will be 2 natural log of 7, and then don't forget the plus c.